Hey everybody, welcome back to the 124th episode of Taps and Patience. I am AJ with Subtract Manufacturing and Audacity Micro, here with Harrison of Precision Ingenuity. I feel like I say something else in that intro, but it's been so long since we've recorded, I don't remember what it is.
Yeah, I know. We're kind of rusty.
Yeah, we were able to do a couple fill-in recordings with like Jacob, and we had Justin from Toolpath on, but you have been gallivanting back and forth across the border.
Yeah, I have. I've been to Canada twice over the last month. So, in two different areas.
I was about to say, as I understand it, you left for Canada. You were there for, I think, 2 weeks. You came back for a week, and then you went to Canada for another week, and then you came back? Is that what happened?
Yes and no. So, which is my famous phrase, apparently. Yes and no. But we went up with my family to Michigan for a week and kind of went around with them. Then we separated. They dropped us off in Chicago, and then we flew up to Canada from Chicago and spent a week up there. So that was my first 2 weeks. Kind of a week in kind of the northern part of the U.S. and then a week in Canada. And then we came back for a week, and then we flew out to Seattle with some friends and then drove up to Canada in a rental car and spent about a week and a half driving around Canada in the BC area, and then came back down into Seattle and flew back. So
did you get to do anything manufacturing, machining related, or was it all just kind of fun?
It was all fun.
Manufacturing isn't fun, but
yeah, it would have been fun for me, but there was 3 other people, so I didn't really get to do anything manufacturing on the second trip. The first trip, I got to go tour the guy who does why is his name eluding me? Lakewood Machine and Tool.
Okay.
I got to go tour their facility on the first trip, which was a lot of fun. And then the second trip, I didn't get to do. I wasn't able to coordinate with anyone to go see, but we were pretty busy. We were running around. My wife and one of my friends' wives. It was me, my wife, and then a guy that I've gone to school with since I was in kindergarten, and his wife. And both of our wives kind of planned the trip, and me and him were just kind of like, all right, what are we doing today?
Yeah.
So my wife, the reason for the 2 trips, because I know I'm going to get this question, why did you go to Canada twice? It's because my wife is a dual citizen. Although she's lived in the U.S. pretty much her whole life. She spent a couple years in school in Canada, in high school. But other than that, she's lived in the U.S. And after we got married, we were going to go up to Canada over our honeymoon and get her passport changed out. But it was in the middle of COVID, and that never happened. And so it took 2 trips up there, because we had to go up there and she had to take a photo and get some other stuff done. I don't know all the details of what it takes to renew, but she had to renew with a name change. And so it basically ended up that she kind of needed 2 trips up there to get it done. And so that was kind of her justification for getting me up there twice. So, and then we kind of vacationed as well. So
cool.
But yeah, it was a lot of fun. Went all over. And yeah, I mean, I can go into specifics, but none of it's really machining related. So, but yeah, it was a lot of fun.
Well, it's actually, I mean, there is a business element here where if you've read any of, I think it's Mike McCowitz talks about how business owners should go on a vacation once a year, and it should be a relatively long vacation to make sure the business can function without them. And it's kind of a shakedown to find areas of your business that are dependent on you and systems that are bad. Yes. So how did the shakedown go?
Well, we were super busy right before I left the first time, and we've been slow the whole time I've been gone. So it hasn't been a problem. Good and bad, because
money.
So like our net 30 is down like 70% from when I left, just because we haven't been shipping as much stuff over the last month. So part of that, was good because it didn't mean that Weston was stressed out from trying to get parts done, but there is going to be stress on the back end because our net 30 is a lot lower than it should be normally. But our we have a trend where every time one of us goes on vacation, something major happens.
Mm-hmm.
And I am proud to announce that that trend is still true. So, in that sense, and I kind of mentioned it last time, but we picked up a new customer, those medical parts. So the week that I was back, we machined those parts, which we can get into detail because they were like 52, 53 Rockwell HRC. And
Mm-hmm.
so tooling, I've never machined anything that hard. The hardest I've machined before that was around 30 Rockwell. So it's a pretty big,
4140, basically.
yeah, pretty big jump. This is a 420 stainless, which is basically
Okay.
steel. And we sent those parts out to the medical company, and they looked at them, and they came back perfect except for one dimension, which was a tight tolerance internal bore. And we had a digital bore gauge that we were sticking down in it, but it has those 3 points that came out, and I think it was tapered, and so
Oh.
it was averaging to being right on size, but they're using a CMM, and I think they're swirling at the top, bottom, and middle of the hole, and it was out of spec somewhere in there but it was consistent. And so they were really excited because the parts were fantastic except for that. And the part that was out was super consistent. Like they could tell it was something with our measuring method, not the machining. So I think they're going to send us an order for, like, we did the first 10, and I believe they sent us a PO for 200.
Wow. Okay.
We just gotta fix that one issue. So
Is it something that you can't just get like a gauge pin in? Is it
we
not
could probably
blind,
get a
but
gauge pin. We could probably get a gauge pin in it, but the problem was like a taper, and we ordered a CMM, so that should be coming in the
oh,
next.
yeah.
That
Just
should be
drop that
coming.
news.
Well, had I not mentioned that?
Not to the podcast.
Okay, well, we bought a Zeist, or not a Zeist, Hexagon CMM on my first trip. So on our first trip, when we got contacted by this medical company, we bought a CMM, which we were planning on buying anyways for Walther. They were hounding us to get one, and we were
Mm-hmm.
looking for one more excuse to pull that trigger. And this new company came in and said it was required for us to do work for them. They would cover us under the short term to get going, but we had to have it on order and coming in for us to get the job. And
Interesting.
so
Okay.
Weston placed the order, and we did the 10 parts before that machine came in. And the machine hasn't come in yet. I think it's supposed to come in either the first or second week of August. I think the second week of August, because this is technically going to be the first week, and I think it comes in next week. So,
How many parts do you have to run for this company for that to pay for itself?
well, it's not just them, because Walther's technically been wanting it, and we're also in the process of getting all of the ISO certifications as well. So
Mm.
since I've been gone, Weston has been buried in paperwork trying to get all the certifications. So we're getting the certifications for medical, and I think he's going to go ahead and get aerospace, and I think one other. And so these are all certifications we were looking at getting at some point. I know some people get scared of getting certified or don't want to do it because of all the extra hassle, but that's the reason we chose Pro Shop and went that route, is so we
Yeah.
could do that. And there is a pretty big upcharge for the parts once you are certified. Like you can charge more for them. So we'll see how it pans out in the end, but it is one more differentiator for us in the area. So
Cool.
we're officially starting down that path. So even though I've been gone and there's not been a whole lot of machining, there's been a lot of business transformation happening.
Yep. So,
So
how are your employees doing?
good. Our intern, I think he's got maybe one more month,
Okay.
and then he's going back to school, and then we'll be back down to just our part time guy. And so far as I can tell, he really likes it. I got to get his skills up higher. He ran his first part the week that I was back on vacation. So he programmed it while I was gone. I came back, I looked over it with him, and then I helped him run it in the machine. I tried to let him run as much of it on his own as possible. And then he programmed his next parts while I was gone. And so tomorrow, or I think he comes in on Tuesday. I think he's Tuesday, Thursday right now. So when I come in on Tuesday, we're going to look over everything that he's done while I was gone. And I'm going to help him or try to let him run as much of it as he can on his own so we can eventually get him to where he can start programming and running parts on the machines. So,
Sweet.
and then if we can get him where he's more useful and able to program and run some stuff, which kind of sucks because Toolpath has been doing like a whole bunch of promos, but I think they all end and they all were active while I was basically gone.
Mm.
And so, but I thought about trying to get Toolpath and letting him use it as like a teaching aid or as a programming aid to try to supercharge his ability to start making parts. So, but it's kind of an interesting question though, and I'll leave this one up to the podcast. So, for someone who's new to machining, we've argued for a long time that you don't need to learn manual machines before you start using CNC machines. As these AI tools become available to us, do we still need to have people program full parts and learn how to do everything without the tools, or do we shove them straight into the tools and then just teach them how to modify it based off of what experience or something else?
That's an interesting point. So I started a new class with the DOC a couple weeks ago. And with this one, I was like, okay, I need to put my money where my mouth is on what I've always said about how to teach these things. Because I've always said, don't bother with manual machining, start with CNC. But with this class, like there's requirements that I don't get to choose
Mm-hmm.
on what they learn. And it's like 2/3 manual machining and 1/3 CNC. Actually, it's probably
Mm-hmm.
okay. It's 1/4 CNC, 2/4 manual, and then 1/4 like metrology, print reading, health and safety. But I have always taught it manual lathe, CNC, or manual lathe, manual mill, mill, CNC lathe is how I've always taught it. And with this class, I went, no, I'm starting with CNC mill. And I don't regret that decision at all. The rate that students have picked up skills has been a lot faster because with manual machines, they were focused on the mechanics of moving the machine, plus measuring, plus fixturing, plus, inspection and work holding and cleaning. And like there's a whole bunch of things they had to learn at one time. With CNC, because I'm giving them the programs. Basically, they get to focus on like, okay, load a tool, set a tool, put part in vise, run program, and then measure part. And it kind of, they're not trying to do multiple things at the same time. They're not having to think about strategy yet.
Mm-hmm.
Whereas with the manual mill, they would have to think about strategy at the same time. And I think it's going to work much better. The class isn't over yet. The other problem with teaching manual machining first is we always ended up rushed on the CNC machining because the manual machining projects always took longer than I thought they would. So yeah, I'm now teaching CNC machining and then manual machining in my classes and intertwining all the inspection and safety
Mm-hmm.
stuff and all of that while I go along. But I'm a believer in that now. With programming, you bring up a good point because my instinct is teach them traditional CAM first and then let them do some automations with Toolpath.
Because if an automation program spits out something that's wrong, unless you have the experience, you're not going to be able to catch it.
Yeah, I bet in the future when Toolpath is bought Autodesk and become a bit kind of the standard and everyone's doing the same thing and it's good enough where you can rely on it for a much higher percentage of the parts to be, maybe not perfect, but like
Much
able
better.
to run without supervision or without
Hmm.
too much added thought. When it's that good, I think it probably would make sense to teach it first if it's the industry standard. Actually, yeah.
Yeah.
Okay, that's what I'm going to say. Teach the industry standard first, and anything else is good background knowledge. If AI programming is industry standard, then teach that first because that's what's going to get people jobs. And that's kind of the goal of these classes. Like, my goal is not to preserve the art of manual machining. The goal is to get these people out of jail and give them jobs. And they're not going to get a job manual machining.
Yeah.
Um, but they will get a job being able to load parts, and that'll hopefully transition into, a job where they're programming or something.
Yeah. But I see the value of I've always seen the value of Toolpath, but as a solo or with one other guy, the value of it hasn't penciled out for how like we're getting to the point where we're running enough repeat jobs that I'm not really
Yeah.
setting up enough stuff from scratch. But if I have a new guy that I'm trying to train up, and then if I can give him a tool where he can program at a similar level to me without having as much experience as I have, or start to gain that knowledge, it becomes a lot more beneficial.
Yeah.
So if I can start giving him projects around the shop, hey, I want you to machine up something for the shop. So for example, when we bought our Lang plate for the UMC 500, the salesman we were talking to had a trash Lang plate that failed. No, it didn't fail inspection. A customer had ordered it with a unique cut and then
Mm.
backed out, and so they couldn't sell it as like a normal one. And so he basically gave us a really good deal on it, and we mounted that Lang plate to a table with the intention of being able to make Lang plates for like a table vise or a table press, and to be able to change out tools on a table that we're using. But I've never had time to machine the aluminum adapter plates to be able to mount this stuff and to use it. And so that's what we're doing with the our employee. That's his first project. And
Cool.
so as we get projects like that, like, hey, I want you to machine something for the actual shop, it's not a job shop, that could be a great tool to help them in those instances as well.
You could even use it as like a vice loading station, because that's something I wish I had right now is a Aroa mount, like an Aroa base, I guess you'd call it, that I can put on my desk or on my workbench and use it to load and unload vices. Because those
Yeah.
things are kind of like, they've got a big old stud on the bottom of them, and it's not like the Lang plates where it sits evenly on four. It's
Yeah.
like one big one in the middle, and like trying to torque a vice when you're holding it or whatever it just doesn't work. So I need
Yeah.
a row amount on my bench.
Could you make a here's a product idea for someone out there. Could you make a cheap Aroa base that's not repeatable but strong enough to mount to a table for a situation like that?
I couldn't make them for the same price that I could get a cheap import one.
Oh, okay. So they had cheap import ones that you could use for
Yeah.
that. Okay.
I mean, that's what my base plates are. My bases.
So you just need to order another one and mount it to a table. So fair enough. What else do we got going on? We've got a first order for 100 guitar parts. So they've
Guitar?
been guitar parts. So we had another customer before I went on vacation that was going to do guitar parts, and so we did the first prototypes, 3 to 5 piece order, and then they placed an order for 100. Now with that, they really like lots of different materials, so this could end up being a part where it could be high volume aluminum, or it could be a mix of like stainless, brass, titanium, lots of different materials. I made the mistake, or you can call it a mistake, you can call it whatever it is, but they were asking about what materials that we machine, and I was like, hey, I mean, if you're interested, they make stuff that's called like Damascus or Timascus, or I was like, it's insanely expensive, but if you're looking to do something, and they looked at that and they're like, their eyes popped out of their head and they're like, that is the coolest thing ever. And I was like, yeah, you ain't selling those for cheap, by the way.
Yeah.
Like these are
Especially
going to
Thai
be
mascus.
these are going to be extremely expensive if you want them, and I am not going to do them in high volume. I might do a batch of 20 at a time, but that'd be about it because it's just too much to deal with. But I don't mind doing, like, if you guys want to do a special edition run, for your high end customers, and then sell these for a premium, like we can do that. But I'm not,
You
because I do know that like some guitar people, like they really like everything chromed and or looking really good. So
you could always send the ones you don't want to subtract. Just saying.
so anyways, so we're looking into that. We'll see how these first ones sell. I hope they do well, but we'll see. Um, it could solve a need, um, but we'll see how well it does in the wild. It's one of those that could be a good idea. It could also be solving a problem that's not really a problem. So
Yep. So I've actually been doing machine shop stuff while you were gone, not just all
yeah,
teaching.
yeah. Are you? And you're still machining at the house too?
Yeah, yeah. Like for Audacity Micro, you could consider it. So I did have a class. I taught a metrology class at it's called Allison Transmission. They make tons of transmissions for both military and kind of normal vehicles. They are the ones I'm going to be teaching for a ton over the next like year.
Mm-hmm.
They have me booked for it's like 3 weeks a month for the next 11 months.
Mm-hmm.
So I get to train every single one of their setup machinists, which is kind of cool because I can kind of have my pervasive ideas go throughout their system. Um, they have they've been having some like quality issues, and they've been having they have some major kind of machine process issues. And like with the metrology class I just taught, I was very much like I taught them kind of modern metrology practices is really what I did. In process inspection, as you know, I'm a big fan of. I taught them a lot about that.
Mm-hmm.
Building feedback systems, Pokeyoki, that kind of stuff. And with the setup class, I'm going to try to teach them kind of more modern setup techniques with even just like setting a common 0 point on a vise or a common
Mm-hmm.
work coordinate system and then probing, driving off of that. They don't do vice work at their plant, but they don't understand the concept of having a common work coordinate system and then probing off that. And that would benefit them a lot. They don't understand 0 points, so I'm going to use Jamie's anchor point system that he sent me. I've been using that as a teaching aid, and so I'm going to have him make some pallets for it and run some parts. They asked me to design a capstone project, and they asked me to do a clock. It's like, hey, can you have these guys build a clock in 3 weeks plus all the other training? It's like, clock is a little bit of a specialized thing.
Yeah.
We're not gonna machine a clock in 3 weeks. Sorry, and I'm not the right person to teach somebody how to make a clock.
You mean a metal case we can stick a clock into? Because we can do that.
That's true. Well, and it's a transmissions place. So they do a lot of gears. So they're like, just machine the gears. And I'd be like, okay, so gear machining is kind of a specialized thing too.
Mm-hmm.
And they aren't doing them on mills. They're doing them on gear hobs. And they asked me to train that stuff too. And I had to be like, wrong person. Sorry.
Yeah.
Go to the manufacturer for that. So, but that's why they wanted a clock, because clocks have gears. And I was like, I need to find a different capstone project. But I figured I can have them make a couple pallets with the anchor point. And because the anchor point pallets are so cheap and easy to make, because they just need like a BT30 pull stud and 2 dowel pins. Or no, the dowel pins there's already dowel pins on the base. It's just 2 reamed holes. So they're super quick and easy. And cheap, most importantly, because I could just do it out of a piece of aluminum and then save the pull stud between the different classes.
You could.
And maybe I'll
go ahead.
Oh, I was just gonna say, and I'll come up with something. I don't know what it would be yet. It's not going to be a clock, but something that requires like 10 different parts that they can do as like their capstone project. And I'll maybe have them like do it once all in vices and then once all in pallets or something. I don't know. I haven't gotten that far.
I was gonna say you could do 2 gears because you could mesh 2 gears and then have them try to see the tolerance stack up and how well they mesh, and and make them large enough that you could do it with like a 1/16 or 1/8 inch end mill
Yeah.
for the meshing, and then then between just that alone will kind of really show how tolerance stack up and how all that stuff kind of interplays together, because gears is something that, yeah, it's a specialized form of machining for sure. But you can do simple stuff. It just still takes a lot of time and effort to do, because I've done it. I've had to do it for a couple
Yeah, I've
customers.
made gears too. But on a VF2 with a 7,500 RPM spindle,
Yeah,
I'm good.
yeah, it'll be slow, that's for sure.
But I don't know. I'll need to find a good project to do. I don't know what it is yet, but I'll find something that has a couple pieces. One of my first mill projects that I do with students is a set of like stacking boxes, kind of like a gridfinity bin, but not. And those
Mhm.
are really good at showing tolerances too, because you can like I've made the tolerance between like the bottom boss that fits into the pocket of the top of the next bin. I've made
Mhm.
that fit pretty tight. And so if it's off, it's pretty noticeable and they won't stack right. Um,
I was
anyway,
trying to
I got sidetracked there. What?
I was trying to think of a fun project with like portions of a gear, and I just had a thought. Could you make like a little catapult that's gear driven where you push down on it and it speeds a lever?
That'd
That way you're
be
only
cool.
doing like a small section of teeth, like five or six teeth, and then a small gear, and you just push down and it would fling it. I don't know, just a thought.
Yeah.
Um, yeah.
So I got a little sidetracked there. Machining wise, so I finished up that big production job that I've been working on since the end of last year. That, of course, it went great until the last 25 parts, and then everything fell apart. And the last 25 parts, which I should be able to get done in a little bit more than a half a day, it took me like
Mm-hmm.
3 days. There was there was a whole bunch of problems with it. Part of the problem is I was teaching the DOC class and I was only able to work on it half the day,
Mm-hmm.
and um, my wife was going to run it the other half of the day for me, and I should have like finished on the first day, but before that, on the weekend, Scott had come in and I was kind of teaching him some more machine stuff. And he loaded one of the tools for me, the roughing tool for that job.
Mm-hmm.
And he loaded it a little bit incorrectly. And that caused the tool life on there to be really bad. And so that tool broke like on the first day. So I came home, I replaced the tool, and it's not Scott's fault. It was my fault. I did not supervise him or teach him correctly. And so I came home, I changed the tool again, put in a new one. I had like one spare after that, and I have a version of the program that strips out all of the probing that I
Mm-hmm.
use to restart in the middle of a program. Like if I'm ever, if there's a broken tool and I need to go back and run it again, it can't try to probe somewhere that I've already machined away. So I have a version of the program with no probing. And I had used that version of the program, and then when Elizabeth came in to run parts the next day, she didn't
Oh
change it
no.
back. And again, I did mention it to her, but it was like a passing comment, and she had a lot to keep track of. And it was fine for a while, but eventually, I think a part just ended up a little bit too off center and broke that end mill. So then I was
Mm-hmm.
on my last end mill, and I'm not sure what happened here. I think a part was loaded, like either it wasn't quite clamped down all the way or is loaded at like kind of half catching the vise or something like that. But that broke
Mm-hmm.
the last tool. And so then it was like, oh gosh, because I didn't order more because I was almost done with this job. But for like the last 10 parts, I had to reprogram the job around different tools because it was a fairly weird end mill that I was using for the roughing.
Mm-hmm.
It was a relatively long corn cob 3/8 bullnose.
Mm-hmm.
Um, and so I had to go back and reprogram it to fit the tools that I had. And the last 10 parts like took me forever. And then that put me behind on the Subtract job that I was working on. With Subtract, Audacity Micro is a vendor for Subtract. So technically I was doing it as Audacity Micro, but it was for Subtract to make things
Mm-hmm.
confusing. And so I got started late on that. And I'm actually still like, I'm going to finish it up right after this podcast. Also, a tool broke on that, which is why I haven't changed out any parts in the middle. There's a little
Oh,
1/16 inch end mill. And it was the first, on the first part after I hit go for the podcast, that tool wore out on me too.
I was wondering why you weren't running in there changing out parts in the middle of
Yeah,
this.
okay, so going back into the story of that Subtract part, it's, you know, those Lego parts that are used to like connect
Lego
one of their
Technic.
little cross-shaped, yeah, like a Technic to connect one of those cross-shaped axles with like the peg that you plug in to the side of a Technic part. It looks like that, except maybe 4 or 5 times scale. So there's a cross on one side, and then like kind of a barrel, and then inside that barrel there's a cross that
Is the negative.
is the negative of the end. And you're supposed to like be able to stack these things like they extend. I think it's like an extender for a switch, like an electrical switch or something like that. But so the way I've been making these is I'm really, really happy with.
Okay,
So
how are you making them?
It should be a live axis lathe part. I don't have a live axis lathe. I don't even have a lathe. So I used a collet block on my Aroa system. So like a collet pallet for my Aroa system. I finally got my Aroa pallet set up the way I originally intended, with one of them being horizontal and one of them being vertical. And I bought precision ground stock that was the right OD for like the barrel section. And I cut it to length. I put it in that collet block and run one side, pull it out and index it 180 degrees with the Aroa system, run the other side, pull it out again and run it vertically with the Aroa system, all staying in that collet chuck throughout the whole thing. So I do 3 operations in a row with that Aroa system, and then pull it out and, you know, machine the next part. And then it gets flipped into soft jaws for the other side. But this system was always like, before I even got the Tormach, this was my plan on how I was going to set it up, is like a pseudo 5th axis, because I can access 5 sides of the part. So it's kind of like 3+2. And I set it up on that machine. And then the first thing I did was take that big production job where I had to turn the Aroa pallet like back vertical and have 2 vertical Aroa pallets or Aroa bases. And this was the first job I got to actually test that theory of my little, you know, like total, I'm like $800 into this system, and I'm kind of using it I'm kind of getting 5th axis work, and it worked beautifully. I didn't see any like taper in my parts. There was no like centering accuracy issues. It just worked the first time. It was a little bit slower because I'm having to like move around the part every operation. Like I couldn't one piece flow 3 ops at the same time. I was doing, you know, 1 at a time. But it was about 7 minutes per part to get the first 3 ops done, which isn't too bad. It was like 2 minutes, 3 minutes, 2 minutes, or something like that. But then I had to do the little matching shape. Imagine it's like a Phillips screwdriver head on the other side, but it's really deep. So it was a little plus shape that was 3/8 deep. And that has turned out to be a little bit slower than I thought. And I'm breaking my long reach 1/16 inch end mills too fast. So I'm almost done at this point. Like I've basically figured out my issues. I've got like, I don't know, probably 7 left at this point. But I'm down to 2 end mills, and I started with 8.
How many parts is this job? You might have mentioned that, but I don't remember.
Yeah, it's only 50.
Okay.
I started off just kind of ramping down the plus sign, and I was getting a tool life of like 3 parts. And so then I started pre-drilling in the center, and I
Mm-hmm.
started getting a tool life of like 4 or 5 parts. And then I switched to drilling in the center and then coming in with a regular length 1/16 inch, and
Mm-hmm.
then going back with the long length 1/16 inch and cleaning up just like the last 1/4 inch. And I haven't broken a single tool since then. So I have the
Yeah.
process sorted out. I'm behind.
Are you using an adaptive toolpath, or are you able to just walk around the profile and that cleans up everything?
Just walk around the profile.
Okay.
I do like kind of it's actually in the CAD model where there's frog toes or Mickey Mouse ears, whatever you want to call them. So I drill those first two and then go
Okay.
around with the end mill. The other thing with those parts, which I didn't realize until like this morning, is I think when I was roughing them or when I was doing the plus shape, like the male plus shape, I think my end mill was slowly the corner of it was slowly breaking down, and the
Mm-hmm.
corner radius got slowly bigger over time. And the I was holding pretty tight to the tolerances, like way tighter than I needed to for these parts. The male one was like +0 -10, and the female one is like -0 +10. So basically, there could be as much as 20 thou um, clearance, but I was holding things pretty close to the zero end of that instead of the wider end. And as that end mill's corner broke down, they started to fit tighter and tighter and tighter. And so I have like half a dozen where I'm not happy with how they fit together. So I haven't decided what to do about those yet. I may need to like put them back on there and zip off a corner or something. It should be a pretty quick thing, but
Fair enough. I do have a question for the podcast now that you're talking about tools and whatnot. Does anyone have any recommendations for hard milling? Because if I get doing these jobs, my tool life was about 5 to 6 parts per end mill. And I'm just using Jelly Bean Haas tools at this point, 1/8 inch. I'm thinking about going up to 3/16 because I can. That's about as big as I can probably go for some of the milling on these parts. And that will probably help. But it's Rockwell HRC 50 to 55 range. And I'm not sure if I should try. I tried Haas's feeds and speeds. I thought about it afterwards, but I should have looked up on Frasia's website to see what they had for feeds and speeds. I've thought about using Frasia tooling, but probably not their generic line. They might have a line designed for harder materials. Kennametal, Harvey, or Helical. Those are kind of the ones I've been thinking about. But if anyone has any suggestions or knows of any lines dedicated for harder tooling, reach out and let me know because I'm on the hunt for. It's both mill and lathe because these parts are have a lot of heavy turning on them, and then just a couple milled features afterwards. If we ever do get a dual spindle y-axis lathe, these parts would be perfect. They'd be one and done on that machine. But they have some milled features on them. So
I mean, there's always the classic Moldino and NS tool. Lakeshore Carbide has a hard tooling line that's really good.
mm-hmm.
You're not you're not super hard. Where
No,
I
but
don't know if the NS tool and the Moldino would be worth the cost.
that's I got to find the right value part, the right value tooling because right now I'm getting 6 7 parts. Like it breaks on the seventh part every time. Like we ran a batch. We only needed to do 10, but I think I ended up running about 20, just between all the testing and trying to get everything dialed in. And so we had some extras that were supposed to be good, and we had some extras that were out of spec. But it was breaking pretty much on the seventh part every time, or sixth or seventh. It never made it past seven.
You
Either
said
broke
eighth
before
inch.
1/8 inch, but I think I can do 3/16 on these features.
Are you using a bull nose?
I've been using a flat, a sharp corner, because that's I think they call out for a sharp corner on the inside edge. So I'm cutting not quite a keyway, but something kind of like a keyway, but it goes all the way through the part, and it looks like it's got a sharp corner in the model, and everything else is so tight on this. I could ask them if I can put a radius on it, but they don't have it in the model.
Well, you could even rough and then finish. Rough with
Yeah,
a bull nose, finish with a corner
right
with a flat
now
end mill.
the way I'm holding these is I'm holding them in the 5 axis, and I'm holding them with the Lang chuck, and I only have one 6-inch gauge length ER16 tool. They can reach all the way down past the chuck, which is why I didn't use a bowl, and then I didn't use a rougher and a finisher because I only have one. I can get another one of those if need be, but I only had one of them, and it was such a small run that I didn't worry about it. But if I start running these production, I will need. I could do a rougher and a finisher.
You said 6-inch ER.
ER16, 6-inch
Six.
length, 6-inch length gauge or tool length.
Yeah. What about going to like a heat shrink or something? Because that's pretty long.
I've thought about it. I still want to go to RegoFix is my goal, and if things continue the way they are, that should hopefully be the next big purchase we make.
Yeah, but a heat like a 1/8 inch heat shrink holder from Marator or whatever is I don't know, $150. Or Shars has a pretty good line.
Yeah, I'm not worried about tool pressure on these. They're such a small end mill that
Well, run out with hard milling is of the utmost importance.
I'm checking
It's
all of them before I'm making sure that they're
okay.
running true. So I made sure all of my tools were running within a tenth or two before. I didn't just stick them in there and run. Like on the longer reach stuff, I always make sure that my run out is good. It takes a little bit more time, but I'm sure it takes probably the same, if not less, time of manually heat shrinking a tool in.
Yeah. But what's your feed per tooth? Because on an 1/8 inch end mill, you're probably at with if you're hard milling, you're probably at what 2 or 3 tenths.
Yeah, somewhere in that ballpark.
That's your run out. If you're one or
I'm
two, like so, one tooth there is taking a much bigger load.
maybe, but they were breaking at basically the exact same point. Like it was a very linear path that they were taking. Like you could every time they ran, you could watch the dimensions of it change by the exact same amount from run to run. And so like you were constantly adding a constant wear offset after every run until it got to like I think 4 or 5 thou of like wear comp, and then it would break.
Yeah, I'm just saying it with like a tenth or two seems like a small number until your chip load is a tenth or two, and then it's
Mm-hmm.
suddenly 100% of your chip load. Like
Mm-hmm.
you have to be careful about small numbers that way. You may
You
even
do.
need like a more sensitive indicator to dial them in.
Yeah. Yeah. But at that point, I'm not confident that I could manually heat shrink something and not cause some sort of warpage that would cause a tenth or two of run out as well. Because you got to heat those pretty evenly as well, I believe. I don't know for sure. I mean, I could be talking out my butt, but my understanding is that you want a constant heat all the way around to be, and that uneven heating can also cause problems
Okay, so
with the
next
torch
question. Haas tool 1/8 inch end mill, you know,
price,
coated 4 flute, 5 flute, something like it's
like $10.
$12. Yeah.
Yeah,
Can you just throw it away every 6 parts?
possibly, but I want to get good at hard milling because a lot of their parts are hard, and so it's more about dialing in a process for hard machining and getting tools that are good for that process than making it work and just replacing it, which could be the answer. But I don't want to assume, I don't want to start out down that path without trying some other things if I'm going to be doing a lot of it.
Fair.
I want to do the research. I want to experiment. I want to try some things, and then dial in acceptable process. Where, hey, maybe 7 or 8 parts with a tenth or two run out it's because of that run out. Like you said, maybe it's 100% spindle load or chip load on one tooth, and that's what's causing it to break. That could very well be my issue, but I don't know at this point. I couldn't tell you for certainty if that was it or not.
Yeah. Lakeshore has a 1/8 inch 6 flute hard coat or hard milling end mill for $20. Might be worth trying.
Yeah, so I mean, like, it's $20 and it lasts me, if I'm
Twice
getting,
as long.
yeah, twice as long or longer. Let's say I get 25 parts out of it, then that's better. I
Yeah,
mean,
they also have a 3/16.
even if it was exactly the same amount, let's just say I went from 7 parts to 14 parts, or I wasn't getting seven. It was breaking on the seventh, so 12 parts. So if I was getting 6 parts and then 12 parts, but I only had to set up a tool half as much, that'd still be better.
Yeah.
So same thing with turning inserts on the lathe. They were only lasting like a similar amount, like 6 or 8 parts before they were wearing out. But like I said, everything that we've been using so far has been general tooling. We
Yeah.
haven't got anything specialized for hard milling yet. So,
Well, speaking of hard milling, we have Patreons.
and they're hard on
All of
us. No,
yeah, actually, they're very not hard on us.
no, they're great.
All of our Patreons get access to our weekly Q&A, which I think I might have to skip today. Sorry, guys, but we'll do it next week. All paying Patreons, and yes, you can join Patreon as an unpaid tier, but all paying patrons get early access to our episodes when we actually record them, and access to our Discord server, which has been super awesome. I hired a second person out of our Discord server this week. I don't think I mentioned that at all. So, oh, but I haven't done this in a while. New Patreons. New Patreons are Kurt, a Confounded Machine. I've been listening to their podcast. It's Kurt from Confounded Machine with Jamie, JSpec Engineering. He's the anchor point guy.
Mm-hmm.
Oh man, I'm so struggling today. Kurt's new. We have Josh C, who's the guy I hired. James at Moultrie Made. Those are all of our new Patreons. And then our existing $10 and up Patreons are Ryan at Strato Manufacturing, Austin W, Kyle K, Devin at Sinister Machine Works, James N, Bennett Prickly Pear Prototypes, Cam S, Shep at Alderson Prototyping, Jacob at Zone and Precision, who I also hired, Jason S, Joshua H, Christian Z, Freaky Climber, Prescott at 1Z, 2Z Systems, Trey V, Guy L, Alexander B, Scott Design the Everything, Jamie J, Spike Engineering, Chris Syke, EJ Nocturnal Welding, Chris at Thought Bomb Design, and as ever, Jake Brownson. We need to do this more so I'm not super out of everything.
I don't have any more vacations planned for a while, so we should be good. Unless you got something planned.
Oh, I probably should mention this. FabTech this year. I will be there. Jacob may or maybe won't be there. Probably not, but maybe will be there. I'm going to do a meetup at the Articards booth on unspecified day at unspecified time. I need to coordinate with them. I sent them a message. I need to check if they've answered me. But FabTech, Articards booth, there'll be Audacity Micro /Subtract meetup. So if anybody's coming, be there. It's obviously not going to be the same amount of people as like IMTS because FabTech is not really a machining show. It's a fabrication show. But Scott and I always go to FabTech for fun, and it's free, assuming you're already in Chicago. So reach out, send me a message if you want to come to that meetup, and shout out to the guys at Arda for hosting us. It'll probably be like Tuesday or Wednesday.
That'll be fun.
So,
yeah. We could go over questions, but if you got to run,
nope, I got to go change that tool, and it was not the long reach 1/16 inch end mill that broke, so we're still good. It was the stubby one, or the regular length one.
Well, that's good to know. Yeah, I think that's it. We'll end it there. All right, guys. It's been a while.
Wait. I forgot to mention something. I did a shop tour at Coal Iron Works. They make forging presses, and they're working on it's like the first American-made power hammer in a century and a half or something like that. I don't think it's quite done with their prototyping design process, but I got to see it run. It was super cool. I did a shop tour that's going to come out on YouTube soon, and I was on their podcast called the Coalcast. That I think is coming out Wednesday, which will be probably pretty close to whenever. I bet it'll come out before this episode. So go listen to the Coalcast and watch for that YouTube video coming soon. Oh, and send parts to Subtract.
All right, guys, let's try this again. This has been Harrison with Precision Ingenuity signing out with AJ from Subtract/Audacity Micro. And yeah, thanks for hanging out with us. Sorry I've been gone for so long. Hopefully things should kind of settle out down and I should be back for a lot more consistent. And yeah, thanks for hanging out, and we'll catch you all next time. We'll seize the day. Taps and patience, our daily grind. In this machine shop, we'll always find joyous struggles, all intertwined. Taps and patience, one of a kind. Bye.